Hi, this is Dr. Mercola, and today I'm joined by Dr. Don Huber, who is an expert in an area of science that relates to GMOs, and it's going to help us understand some of the nasty insider tricks of what's going on with this GMO issue. And he's actually gotten quite a bit of notoriety for his expertise in this area. So welcome, and thank you for joining us.
Thank you, Dr. Mercola.
I wonder if you can tell our viewers what your specific training is and how you came to attain this knowledge and information on this very specific area of GMO toxicity.
My area of training is soil-borne diseases, microbial ecology, and host-parasite relationships, so that in realizing that agriculture is a system, not just a bunch of little blocks that fit together, you have to understand how that system works and realize that any time we change one part of that system, we really change the interaction of all of those other components as they work together. And so each time we have a change, whether it's crop rotation or tillage or different fertility programs or herbicide interactions, we see those changes as they affect those components in the system. And so my research over the last 55 years has been devoted to looking at those changes and how we can change them and manage that system for more effective crop production, better disease control, and improved nutrition and safety of our food crops. So when we look at such a major change as you have in a genetic disruption from a genetically engineered process, as we understand it in our limited knowledge now, we see that there are opportunities and actual changes in all of those components as they fit into the agricultural system, from the plant, the physical environment, the dynamics of the biological environment, and of course our pests and diseases as they interact together. So those have been the areas of my research over time and brought me to this point.
So most of the information you're sharing is relatively new and not widely known at all. So as a result, the public appreciation of this toxicity of glyphosate is really limited. So I'm wondering if you can help us, the people viewing this, put it into proper perspective and perhaps relate its toxicity from your understanding as a professional research scientist to one that they might be familiar with, which is DDT. Because in many ways it's similar with reproductive problems and inhibiting many of the reproductive functions. So if you could maybe just help us understand it from that perspective.
There are some similarities. I'm not, again, qualified in a lot of those aspects, but familiar with DDT, the fact that a very difficult compound to degrade, is biologically degraded primarily by a process we call co-metabolism. In other words, there are very few organisms that can utilize it as a direct nutrient source. And there are a few organisms that can utilize glyphosate as a direct nutrient source. But again, most of the degradation appears to be by co-metabolism. In other words, an organism just happens to produce the extracellular enzymes that will degrade it, rather than the organism really getting any benefit from it. So there's not that stimulus in that process.
Does ultraviolet light break it down, like sunlight?
I don't know.
Okay.
Again, I haven't followed a lot of those areas.
Okay.
But we know that it can accumulate for, in some situations, a very short period of time. In other situations, it can persist for years. That'll be primarily determined by biological activity, but also by the soil pH and clay content, how firmly it's sequestered in the soil or absorbed in the soil. So the less movement of the chelated glyphosate into the clay structure in the soil, the more readily it would be available for degradation. by microorganisms. So once it gets moved in, probably not really accessible for degradation, but then can be desorbed chemically. Mm-hmm. The organisms that are stimulated are the pathogens. And just as this paper that I was reviewing and of the presentation that was made at the meetings in Germany 2 weeks ago shows is that Clostridium, for instance, is very tolerant at extremely high rates of glyphosate, but all of the natural biological control organisms are very sensitive relative to that concentration for the glyphosate. What we see with the Fusarium that cause sudden death syndrome on soybeans is that it can be stimulated by the glyphosate. It's not a real rapid degrader, but it can utilize it. But it is stimulated, so we find a 500% increase in root colonization by this fungus. Very serious pathogen, not only on soybeans, but Fusarium on most of our crops is a major disease organism we have to deal with. But Dr. Kremer and others have shown up to a 500% increase in root colonization, even on the Roundup Ready crops, because again, there's nothing in that technology that does anything to the glyphosate. All it does is make it possible for that plant to survive and to accumulate more glyphosate, so that we still change the soil ecology, the microbial ecology, and as this paper from Germany is showing, our intestinal microbiology. Because again, those organisms are very sensitive to glyphosate because they have the shikimate pathway in them.
So this glyphosate is being used as a weed killer, classic weed killer, herbicide. But from what you said, it actually serves as a fertilizer for some pathogenic bacteria. It makes the bad bacteria grow more, and it kills the good bacteria. Very similar to what, in some ways, what an antibiotic would do.
Yeah, be the same type of a relationship, mm-hmm. so that it's not always a matter of whether an organism is present or absent in the soil, whether it's going to cause the disease. It's a matter of what that biological balance is that normally keeps it in check. Mm-hmm. And when you take one side of that balance out, then it's a matter of just having free rein for the disease organism. But with glyphosate, we also see an additional stimulation of virulence, so that we see that increased ability to cause disease, as well as the loss of the natural biological controls.
Now, I'm going to pose you a little difficult question here, just as out of personal curiosity, but I suspect many others would be interested. Virtually no one I know would like to be hit with either a baseball bat or a hammer. Okay. So there is no good answer. But if you had your choice, and you had to use one of these toxins, DDT or glyphosate, from what you understand of both, what would you use?
Oh, there's no question. I would take DDT.
DDT. So that's what I was. I mean, you say that very unequivocally.
Yeah. What I know of both, and I looked at the Triana, Alabama studies and other studies with DDT. I was in a position to look at that. Again, a lot of these materials can have a very beneficial use, and I'm certainly not anti-chemical. Mm-hmm. But we have to use some common sense. What we have with glyphosate is the most abused chemical we've ever had in the history of man.
God, that's a very profound statement.
When you look at the millions of pounds that are applied, at the broad spectrum effects that it has on the ecology, on our ecology that we're dependent on for subsistence, and then we don't pay any attention at all to the fact that there's a purpose and there's an abuse, and we're on a rampant abuse. And when we've gone with the genetic engineered products that permit us to apply more and more of the compound, the abuse is accelerated with the limited knowledge that we have. And I can tell you, when future historians write about our time, they're not going to write about the tons of chemical that we did or didn't apply. When it comes to glyphosate, they're going to write about our willingness to sacrifice our children and to jeopardize our existence by threatening and jeopardizing the very basis of our existence and that sustainability of our agriculture.
It's such a massively profound statement. I mean, and it just resonates with truth. I totally believe what you said. God. So,
it doesn't mean that it's not reversible.
Yeah, I know, but it's just.
But it means that we need to recognize what the concerns are, what's happening, and then we need to change. As a scientist, when we get into this situation, you see a disease that's a very wimpy disease like Gauss's wilt that for 30 years since it was known has been very localized, very limited in its ability to cause damage. And all of a sudden you see the thing essentially throughout all of our production areas as a major factor reducing the quality and the quantity of the food that we need for our population or for the world's population. And we're doing everything that we can to make it more difficult to produce that quality and that quantity of food in the things that we're doing. And you have to say, well, what's changed? And as a scientist, we do that all the time. We look at correlations, we look at other things. We try and figure out what that key point is that's changed. And what we see is the key point is in these products that we've moved with without having the basic understanding of what they're doing, and then have a massive experience based on flawed science and failed promises just to support the bottom line of a few large companies.
Yeah. And just maybe if you can comment on the fact that this seems to be accelerating. It's not getting better, it's getting worse, because not only do we have the introduction of new crops that are genetically resistant to glyphosate, but the glyphosate itself, the main purpose is as an herbicide, so it's preventing the weeds, but the weeds are becoming resistant. So they have super weeds, so they not only have to apply more glyphosate, but they're applying other herbicides. So I'm wondering if you can comment on that, and perhaps as an extension of that, the rate at which the acceleration of the use and how much more of these toxic chemicals are being spread.
Well, you have to start with that glyphosate doesn't kill the weeds directly. Mm-hmm. Now, if you apply enough of it, you can. What we see with the resistant weeds is they're resistant to the pathogens because glyphosate, again, as a chelator, just gives the plant a bad case of AIDS. Mm-hmm. It doesn't kill it directly. It's these soil-borne pathogens that kill it. Oh. So glyphosate turns off the immune system in the plant. As an analogy, it's not quite the same as in an animal, but it turns off those natural defense mechanisms so that the plant becomes very susceptible then to these soil-borne pathogens that are always there. When we have a resistant plant, we've selected them for resistance to that pathogen. And when we add more glyphosate that finally kills it because we can finally suppress the defenses in that plant, then we have also stimulated the pathogen, but we've also drastically altered that microflora from a beneficial standpoint that we rely on for sustainability of our agriculture. And so we've destroyed the natural biological controls, we've impaired the ability of the plant to obtain nutrients for the health of the soil, and we've stimulated our disease organisms in that whole process. We've never once considered a judicial use. You can go in and you can look at the advertising and it's said it's very effective on cracks in your concrete driveway or your garden or the rest of the world. We've never considered any common sense that we used to use in the registration of most of our pesticides and say, how quick will it be degraded, under what conditions, what does it, what are the degradation products, what's the overall impact on the environment and the safety. We used to do those things almost as a natural process in evaluation. We don't do that anymore. We've given glyphosate pretty much a pass on any of those considerations because, quote unquote, it was considered safe.
And
The other thing is with genetic engineering. Whoever came up with the term, I know who did, but how they came up with the term is substantially equivalent, can't understand. There's nothing substantially equivalent about genetic engineering and the normal sexual breeding process. I think Patrick Brown, Dr. Brown at the University of California, stated it very well in his document in 2000 when he said that it's more like a virus infection than it is a normal sexual breeding program, where you're inserting a gene just like a virus does. In fact, we even have to have virus coat protein genes and a number of other things to get it to express itself, so that you don't have the normal controls and regulatory genetics that go along with that natural sexual process and the genetic engineering that we would normally have to keep all of those things in balance and in a controlled state.
So it sounds like one of the foundational elements that allowed the problem to get to the point where it is today is this underlying assumption of the safety of glyphosate. So can you comment on how it was perceived to be safe? I mean, this seems a ludicrous assumption, yet it's the working basis of modern agriculture, it seems.
Well, part of it was a failure to understand what the product is, and that's as a strong chelator. They only looked for what the mechanism was by which it killed plants. And that took some time. It wasn't easy to find and to identify the EPSPS enzyme as the inhibitor, because it inhibited a lot of other enzymes also. It's not just a single target type event. And as I read some of the early documents, it stated, it inhibits the EPSPS enzyme, actual herbicidal mode of action unknown. Well, in 1984, it was very well documented that the way it kills weeds and plants is by compromising the defense mechanisms and making them very susceptible to these soil-borne organisms. In sterile soil, it doesn't kill. It will stunt because it's a growth regulator. It suppresses that defense mechanism that also produces lignin and a lot of other metabolites, secondary metabolites and the hormones, but doesn't kill. Most of our herbicides attack a primary mechanism, so that when you shut that enzyme down, then you get cell death or death of the plant. With glyphosate, it isn't. It's a debilitating type of a situation, more like AIDS than it is a direct killer. So there wasn't a clear-cut direct mechanism that was obvious in its use. And it also, since humans and animals don't have the shikimate pathway, it was assumed that this is a pathway that's only in plants and microorganisms, therefore it's going to be safe for us. It was also assumed that the foreign proteins, whether it's BT or whether it's the protein from glyphosate, that new EPSPS gene from the agrobacterium, it was assumed that they would be readily degraded in the gut, and you can put them in a little beaker with hydrochloric acid, and you can show that they probably denature. That's different, though, than what you have in your stomach or in your intestines, and it's a flawed science. We don't really understand even what that genetic, functional genetics are with a normal sexual breeding program, leave alone when it's disrupted by inserting a foreign one. We know that when we insert a foreign gene, we disrupt all kinds of things in the process. It's not just a simple matter of shooting a silver bullet and it does the job. When you change anything in agriculture or in the system, you change a lot of other things. And typically, going back to the question on herbicides, when we would apply an herbicide, we would tell our growers, you rotate the chemistry, just like you rotate the crop. And therefore, when you had an effect on a specific group of organisms, you had an opportunity for that nature to rebalance and to reestablish that beneficial and functional relationship. We haven't done that with glyphosate. We've just continually hammered for over 30 years in one direction on those beneficial organisms so that, again, as I indicated earlier, they no longer exist in the environment. We see that we have to start adding them now in order to maintain crop productivity and nutritional value.
So glyphosate existed prior to the introduction of genetically modified crops?
Yes, it was introduced in 1984.
So about 10 years before.
So,
it would make
actually,
sense because...
excuse me, in 1974.
Yeah, so they would have to have time to utilize it and understand and do the science to get the crops to be introduced. So I'm wondering if you could comment on your perception of the increased use of glyphosate. I mean, is it doubling every few years, or do you have any?
Well, in 2007, USDA asked for permission not to have to record how much use. It was going up so rapidly that it was embarrassing, I think, for anybody to realize how much of this organic phosphate was being put out, or phosphite, which is even has a different chemical category than the phosphates that we have, but it's embarrassing to see how much of it is being applied, and especially when now we can see all of these other side effects from a direct effect on beneficial microorganisms. We're seeing the effect on organisms in the intestinal tract just from the residue in food and feed. So that, and yet we still recently had the FDA increasing residue levels that were permitted in some of our food crops. Reduced it in meat, so that I think it went from 3 parts per million down to 1/10. Didn't give any explanation for that. I'm not aware of any toxicology data. But why would you reduce it in the meat if you are going to increase it in your feed and food going into the animal or into our food chain?
So the potential implications of the long-term consequences of this, you alluded to earlier. But I wonder if you could do a worst-case scenario and then integrate within your answer any potential remediation efforts. And what are worst-case scenarios? I mean, are we going to reach some type of critical threshold, at which point it becomes, there's really no way to remediate against this thing? We're looking at the extinction of large numbers of animal species, and even maybe the extinction of our species. I'm just, what's the worst-case scenario in your projection?
I usually don't deal in worst-case scenarios because I'm more of an optimist.
Yeah.
And 20 years of my research was designed, how do we remediate for the downside of glyphosate as far as that nutrient availability and the disease predisposition. And so I really focus very heavily on that area. I don't think that you have to go very far, though, to realize that if we continue in the same direction, that we're going to see the same effect or even a greater effect, because in health, just like in plant diseases, we usually recognize it only after there's been a lag period. And when we recognize that we're only at a small part of that overall lag period, we only see a small part of the iceberg. And I think that's where we are now, where we're just starting to see the full impact, not the full impact, but the impact on reproductive fertility, and also the disease potential, because our diseases, plant diseases, are continuing to increase. Our animal diseases, you can't hardly pick up the paper anymore without seeing a human disease that's involved. USA Today in today's paper mentions the salmonella outbreaks. Well, we recall 20% of our total egg production here last year, early this year, because of salmonella. You have to say, well, what's changed? Newspapers said when they looked at the egg-producing facilities, they had chicken manure and they had rodent droppings. Well, my kids growing up always had 200 or 300 chickens as a 4-H project. Never seen a chicken that didn't have have manure. And anytime you have feed, even with 3 or 4 cats around and whatnot, you're going to have some rodents. That's not the reason. I think with the data that is shown from this German paper now with the Clostridium, showing that it's a problem, and it also shows that E. coli and some of these other organisms have a very high tolerance for glyphosate compared to the natural biological controls, that it may not be the Salmonella's presence or absence that maintains our food security and safety, but the presence or absence of these natural biological control organisms, because Salmonella and Clostridium and a lot of these disease organisms are ubiquitous. They're everywhere. Our health is dependent on keeping them in check. Well, if we're eliminating that check, either through food residues in our food or through direct impact in the environment, we're going to continue to see what we're seeing today. And you look at Alzheimer's and thyroid problems and autism and Parkinson's, any of those diseases that have a tie with either the endocrine system or the nutrient availability, we're going to see those increase. Looked at 6 weeks ago, I was in Australia and had an opportunity to review a study that's ongoing there. It's a takeoff from a study or continuation of a study that was conducted in Iowa with pigs and cattle. And they're doing it with mice so that they can define what the toxicants are, natural toxicants in the genetically engineered crops. But they're using these 1 pound or 2 pound big white rats that some people like to call them a pet. My wife would like to hit them with a broom if she saw them, but you can reach into the non-GMO fed rats and pull it out, put it on your lap, and it can be petted just like a cat. You try and reach into the cage where the rats are being fed the genetically engineered feed, and here they've limited just specifically to 1. The rats are irritated. They don't get along together. They're always go off into their own little world on it. They do backflips as they crawl up on run the cage, can't get any peace, can't settle down. We see all of that increase, very typical of what you'd see with autism. And then you start looking and you say, well, are there any other similarities? Well, when I was in Germany here 2 weeks ago, I had a doctor that specializes in working with children with autism. And I mentioned the study in Iowa where they had compared GMO and non-GMO, and you look at the stomachs of the GMO, they have all of the severe allergy responses, that inflammation and the reddening. But then when they looked at the intestine, they said that the intestinal lining is all deteriorating. Not the same. The smell of the intestinal contents is very rank. The biology has been drastically changed. And this doctor said, well, that's exactly what we're seeing with our children with autism. Now, you need some research, but certainly the indicators are there, and the research up until very recently hasn't been done, and those who wanted to do it have been prohibited from publishing or from doing the research. We see those that dared to come out and raised some concerns that have been very severely impacted professionally, as well as in their own personal lives, and that persecution that they've had to endure. And we've got to change. We've got to recognize that what we have now isn't normal. We've got to get back to a safe and a sufficient and sustainable production and health for our agricultural community if we're going to be healthy in that process also.
I couldn't agree more. You mentioned that you did work for the last 20 years on remediation efforts, and I'm wondering if you could comment on how one would remediate against this deluge of glyphosate that's being introduced into our environment.
Of course, one of the important things, again, is just understanding what glyphosate is as a strong chelator to immobilize nutrients. And so one of the things that we see is that if we'll compensate for that, either the effect of the gene if you're using a Roundup Ready, or the effect of the gene and the chemistry, the glyphosate, if you're using both of them or if you're just using the glyphosate, how do we compensate for that reduced availability? And we can do that in plants with foliar applications of our micronutrients. Usually it takes 8 to 10 days after the glyphosate is applied before you'll have any benefit from a foliar application of manganese or zinc or copper or that, because the glyphosate is still very active in that plant and will still chelate and immobilize it so that it's not beneficial. It may be in the plant, and when you do a soil or a tissue test, it'll say, yeah, I'm in full sufficiency. But when you actually look at the plant, we're seeing deficiency of manganese, for instance, at levels that are twice as high as we used to consider fully sufficient physiologically. But we can add those, we can compensate. Now, a lot of the sources of our nutrients aren't all equal in their beneficial effect on that physiologic process, because they're not all soluble or translocated across the membranes or even mobile in the plant enough to fully compensate for it, especially with a mineral like manganese that doesn't move downward in a plant, it only moves upward. And so we need to look at those techniques so that we can meet the full plant sufficiency. When we do, we can compensate. We restore the disease resistance, and we again have nutritious and healthy food that can be produced. Without doing that, then we see that very marked reduction in nutritional value even when the quantity is produced. But often we see, as we're seeing now with SDS and with Goss's wilt and with Fusarium head scab and the mycotoxins in our cereals, that we can't compensate for all of those effects because of the dynamics of that soil biology, unless we also address that. That's a more difficult one. Most of the products that I've evaluated over the years to beef up the soil biology, most of those organisms are very sensitive to glyphosate. So that even when we add them, we have to wait until the glyphosate is very firmly chelated in the soil, or else we have a toxic entity that totals what we're trying to do. If we do that, and we're having to do it now on a regular basis for our legumes, we have to add the inoculum. Well, for years we haven't had to, because the nitrogen-fixing organisms were able to establish in the soil and develop in that environment, so that all we had to do was plant the seed. Now, since 30 years of glyphosate has taken them out of that environment or reduced their efficiency, now we have to add them again. And so we can do that, but before you do anything, you have to recognize that there's a problem. And this one has kind of snuck up on us. It's, I guess if you wanted to put it with the old Greek mythology, you'd say it's a Trojan killer. Mm-hmm. Because it's slow, it's an indirect effect. It's not direct in those end effects that we're observing. And so you have to go back and look at the correlations and look at where the ties are to get back at the cause. And that's much like the veterinarians did with this new entity, that they, first place after they established that that was the cause of the reproductive failure, they went to the feed and said, well, where's this thing coming from? And that's when they found the soybean meal had high concentrations. We find it in that the fusarium, the fungus that causes sudden death syndrome, can carry that into the plant. And in the plant, it multiplies, grows very well. If it's a living entity, it reproduces anyway. Again, we're not sure how to classify it or where to put it there at this point. Working very hard to get that name. But again, the veterinarians, that's where they found it. We find that it very synergistic with most other organisms in the environment. And at some point in time or in some situation, it may have a beneficial role, just like a lot of other organisms do. But in the environment that we're putting it in or that we're creating, it's an extremely detrimental entity for us to have to deal with. If it's not a living entity, DNA sequencing should tell us that, then it raises another question of what do you do? How do you reverse it? Again, it's new to science. We don't know. We don't have a lot of that basic information because we haven't had to confront it before.
But it would seem to me if you put back the normal mechanisms that existed in the soil prior to the introduction of glyphosate, those the healthy organisms that should balance it out and control it.
This is what's being done with the animals, is the veterinarians change the feed, pull them off the GMO feed, get them back onto a healthy ration. They also have to modify the ration. They cut the protein level down, they modify the nutrient level to get that back, and it looks like that's starting to work for them. With pigs, it may take 3 to 8 months to restore fertility. With cattle, 10 to 18 months. Looks like you have to go a full gestation period, and that's one of the things. It doesn't look like it's a highly infectious entity, which is good news, but that it's in very high concentrations in a lot of our food sources and feed sources, high enough that it persists and the effect of it lasts for some time. Now, what the direct role of glyphosate is, again, in the crop, we don't know that direct effect, except in making those plants more susceptible to the diseases. And it's in those situations where we see very high concentrations of this entity that then goes into the feed and food supply. If we change that, looks like it's, at least in the early stages, looks like it's going to be reversible. Had a number of veterinarians that comment to me that when they apply the synthetic vitamins and minerals, that they're not nearly as effective as the plant ones. So if we're having to complement what's in the plant because it's not there anymore, then we need to really look at how do we make that complementation fully effective. Just a lot of research that needs to be done that hasn't been done. It's ongoing. Again, you asked me what the worst case scenario was, and I think that there's enough innovation and enough inspiration and that can come if we're willing to receive it.
This is true.
But it's just like advice that I give to my kids. If they take it, I think it'll benefit them. If they don't take it, then we make the choices, but we don't choose the consequences.
Yes. Well, it's good to know that it's reversible. It's very good to know. And with your comment on the being aware of this research, that the challenge, I certainly, first of all, applaud your incredible efforts and all the decades of and hard efforts and research you put into understanding this problem, because you're really at the leading edge of understanding the catastrophe that can really be a result of the use of all this glyphosate. And you're seeking actively to engage the regulatory authorities in the United States and have them do what they should have done with respect to safety. But my fear is that there's such massive conflict of interest and such large sums of money being generated that, and you've addressed this, I mean, there's this prejudice within the academic community to not even study this. So the necessary science that we need to have done, which takes years to do to begin with, of course, is not going to be done for years, at the earliest, most likely. And by then, we may approach a limit where it's going to be too little too late, and the long-term consequences could be even more severe and may be more difficult to remediate. So, that's my analysis at least. And, we're seeking with our efforts and an initiative with Health Liberty that we're putting together at our site to reproduce what they've done in Europe, where all they did was require these genetically modified foods to be labeled. People are smart enough to understand that this is not something they want to mess with, so they avoid them, and the industry essentially removes them from the shelves because there's not a demand from the consumers. We fight it with the pocketbooks. So we're engaging in a process and working with a number of other leading organizations in the organic consumer movement to have a ballot initiative in California to essentially will require, if it passes, and we're hopeful that it will. And I'm also excited that we've had this interview because you've given so much wisdom of what the real central issues are. And we're going to be using this in our campaign to really make this the fighting ground, because I think we've lost. I think we've lost in the government regulatory agency. It's my view, it's almost impossible. I hope I'm wrong, but I'm trying to be a practical activist here. So it seems that we need to direct our efforts towards California, where we can get an initiative to require all products similarly to do to Europe to be labeled. Once that passes, I think it's the beginning of the end. I'm really excited about that, and our interview really inspires me more to be more aggressive with this effort.
Well, the consumer should know what they're eating.
That's all it is. It's just let them know what it is.
And give them a choice.
Yeah.
And when you look at what we're seeing, you had that paper, scientific paper, study from Quebec, or the outskirts of Quebec, of those women that didn't have farm exposure, but yet that 93% of them contained the Bt toxin in their blood system. 80% of them pass that on to their children, developing children through the placental barrier, which isn't a barrier for that. Mm-hmm. It's not a barrier for the endocrine disrupting chemicals like glyphosate. Goes right through that barrier, just like DDT did or DDE. It's not a barrier for that. Those effects in that early developmental stage are lifelong, not just lifelong, even for generations, that you see what that disruption does when you have that effect. So that why not give them a choice? Those who want it, that's fine. But for those who really honor that need to protect the future, regardless of what they want to do to themselves, it's a matter of protecting the future. And that's why I made that comment, that future historians aren't going to judge us by how many tons or pounds of pesticide we apply or don't apply, but how willing we are to sacrifice our children and the next generations, as well as jeopardize the very basis of our own existence, all based upon failed promises and flawed science. The only benefit is that it affects the bottom line of a few companies. There's no nutritional value, makes some decisions in farming easy for a time until it catches up with us, as it's doing now. And then, as you said, pesticide use goes up, exposure goes up, our losses, production is lost, and our quality tumbles. What's happening is that it becomes a self-fulfilling prophecy for those who say we can't produce enough food for an expanding world population. Well, he said that in 1758. We've been able to provide that source of an abundant and nutritious food in the past. There's no reason why we can't in the future. If you look at the genetic potential of our crops, it's dramatic, it's amazing. We're only harvesting 25 to 30% of that because of stresses. When you add another stress, you don't harvest more, we harvest less, and that's what we're seeing in the genetic engineering process. It's so subtle.
Yeah.
I mean, it's provided a powerful tool, simple tool for weed control that we've always had to struggle with.
Yeah.
So it's simple, easy to use, removes a lot of management decisions. Anything we use is going to have some effect. It's just that we've never managed any of the side effects. When National Academy of Science said it's substantially equivalent, we just automatically said, well, there are never going to be any side effects from this, or we never anticipated any unintended consequences. It was just that, yeah, you put a gene in that functions. Well, as we know from the Human Genome Project, that there aren't enough genes to do everything. One gene, it's not a gene function relationship. It's how those genes work together. And when you disturb that, you disturb all kinds of things. And our knowledge of that is so premature, so infantile, that to assume that we have these silver bullets that you can just put in a revolver and spin the chamber for whatever stress or problem you have just doesn't work. And in fact, as you look at that, all those failed promises, or all the promises, and you can see how they all failed. You look at drought resistance. It takes twice as much water to produce a pound of a Roundup Ready crop, soybean plant treated with glyphosate, as it does that soybean plant that's not treated with glyphosate. You reduce the water use efficiency because you reduce the efficiency of all of those keys that go in the ignition for these engines that are sitting out here in the plant to do the work for you. You look at the quality, nutrient levels go down, have a third to half the amount of manganese, up to 70% less zinc. Look at your copper and your iron, your other nutrients, magnesium. Again, one of those that chelates very well, is immobilized. Not only affects the health of the plant and the reproductive ability of that plant, but that's what we eat. Isaiah said 800 years ago that all flesh is grass. That's our source. That's the source for our animals. But we need that in the seed just to produce a healthy plant. And so we have to start looking now at mineral supplementation as seed treatments, just because our soil biology isn't going to provide it. The whole system has changed. If we want to change it for the better, we have to recognize what that changed and be willing to change again to compensate or to rectify. I think as when George Romney was chairman of the Citizens Constitutional Commission in Michigan, he was asked what his feelings for science were, and I think he hit it right on. He said, with every scientific advance, we find that there are challenges and problems. And he said, we use science and we solve those problems, and it moves us up to a little higher level. He said, when we get into problems in science is when we assume that there aren't going to be any challenges. And we put our head in the sand and ignore those challenges, and then it's to our detriment. And that's a paraphrase. It's not a direct quote, but essentially that concept. And I think that's what we've seen with everything, that we make advances slowly. We do a lot of it by mistake. But we have to recognize those mistakes, and then we can correct them and move on and better the human condition through that process. There isn't such a thing as standing still.
Sure.
We have to keep moving.
Yes, this professional scientific arrogance over the last 40 years, or 30 to 40 years with the glyphosate, and it's just now starting to emerge, but I guess that's the time frame you'd expect to see a problem, because it's not going to happen immediately. Just like smoking cigarettes isn't going to kill you from lung cancer in a week or a month or a year. It's going to take some time.
Yeah. It's a very subtle effect, but such a broad spectrum impact to affect everything that we need to survive on. It affects us directly through nutrition, through disease. It affects our production capability, that ability to have an abundant source of safe nutritional food at an economic price, and it affects our soil biology, our sustainability, as well as then that direct onslaught that we always have to deal with from pests and disease organisms. So it's, again, agriculture is a system that supports the larger system that we're a part of, and we need to recognize how all of those pieces fit together and optimize them for the best rather than denigrate them to our detriment.
Couldn't agree more. Well, you provide us with a lot of information about a very important topic that I think hopefully will inspire many and motivate them to become active on this issue, because it is so important to not only to themselves and their family, but their future generations. So are there any items that we didn't discuss that you'd like to comment on, or any closing words?
I think I'd say that what I've shared with you isn't just my work. There are a lot of other scientists who've contributed, and I've used their data, and I've cited them. My response to USDA and my publications on this. Mine just a very small part of that research. That all of them, everybody has contributed very critical parts to it, and I'm more the messenger so that the research can continue on and we can get those answers that we need, rather than me really being that prime researcher. I feel like I've made my contribution. I continue in that area. I have a lot of curiosity that isn't satisfied yet, and a lot of understanding that I'm trying to find the answers for, and really appreciate a very dedicated team of scientists and people that I have the privilege of working with and associating with in this area internationally as well as domestically here. Been a tremendous inspiration to see their dedication and hard work in spite of many of the oppositions and pressures that have been put on them to change their direction. It's great to see them moving forward and willing to sacrifice a lot of time and a lot of energy and to give up opportunities for research in other areas because they feel the critical need and they see those problems that we need to address.
Well, I want to thank you for all you've done and for all the other researchers that you mentioned and who are also contributing to this, because it's individuals like yourself who, unfortunately, from my perception, seem to be a minority, who have maintained their integrity to reason why they went into this discipline to begin with, because most tend to be corrupted and with massive conflict of interest, and they failed to do their mission, and as a result, there's suffering that results from that. But it's really people like you, dedicated and committed with integrity, that really do the hard science that most of us don't know how to do or that have the time or resources to do it, and are able to find the truth, the reality of what's going on here, so that we can take some preventive action and really prevent loads of human suffering. I think ultimately that's the foundation of it, is to really prevent suffering. And we're really heading down a nasty road unless we take some very serious course corrections really quickly. So thank you for
Well,
all you've done.
Would say my colleagues have criticized me for not having, for this new entity not being published and out for peer review. That will come as soon as a name can be put on it. All of the veterinarians and others have felt very strongly that if we released the information that's known, and there's a fairly broad base of knowledge that's known, but if we release that without knowing exactly what it is and a few other interactions, it would do more damage than good.
Yeah.
It will be released, it'll be published, it'll be available for peer review. When that name can be put on it so that it is out there, and that's a very critical component, and that's another reason why I'd ask that that letter be confidential, that it not be released, because we needed to have that so that there could be an understanding rather than speculation. Sure. But if we did it now, if we released names and those who are working on it, and some of those we've had to go international because we couldn't do the research here. And so it's an international group of scientists that are involved. But as soon as that name can be tacked to it, it'll all be there for peer review. Sure. Recognize that critical aspect to it, and that's probably a justifiable complaint without understanding the consequences.
Sure, but it's still the stealth toxic entity that you refer to is, in my view, a relatively small component of the whole picture.
True.
So even if that didn't exist, there is more than enough evidence to eliminate this toxin from our environment. Yeah. I mean, there's just profound evidence to do that. So, I appreciate your diligence in seeking to do what you need to confirm the validity of this. But, I would answer to your critics that it's almost irrelevant because it's just a small part of the equation.
Well, as far as validity of the entity for reproductive failure, that's well established and easy to document. Those veterinarians that have contacted me as a result of leaking of that letter, been able to put them in contact with veterinarians who can help them, who can verify it, and been able to do that. That's not a question. It's just that until you can put it in the overall perspective, because it's more than just the reproductive failure in the animals. We're seeing a lot more effect, and you have to know where does it come from, what's its role in the environment as far as leading to this end product that we're struggling with.
Okay. Well, thank you again. Appreciate you coming in and educating and enlightening us about the depth of the reality of what we're facing with this glyphosate contamination in our environment. So appreciate all you do.
Oh, thank you.